Kevin, feel free to share your screen, introduce yourself, and start with the presentation.
All right, so thank you, Gene. All right. Here we go. All right, so today's, I call it the function of windowing functions, just because most people have never heard of windowing functions, or at least at most they've heard the very basics of it. So I like to go through it and at least level set everyone with it to make sure we're all at the same level, at least as much as I can. So I am the presenter today, obviously. My name's Kevin Wilkie. I've been working with SQL Server for over 15 years now. I'm a co-organizer of the DBA Fundamentals virtual group that Gene was speaking about earlier. We meet about every week or so, always on Tuesdays. And I go over the fundamentals or basics of what DBAs should know. And for the most part, what developers that are dealing with data should know as well. I've worked here lately, we've went over things such as CI/CD. We've went over this week, we did Custo query language. There's all kinds of things we cover that are very, very useful for anyone working in the database realm, and we'd love to have you. With that, I've also held many titles of anything with a database, such as SQL Developer, Production DBA, Associate, you name it. Basically, if it comes to a database, I've done it somewhere, somehow. All right, so let's get to the fun part. What actually are windowing functions? So many years ago, I worked with a BA who obviously had never heard of windowing functions. So his first question was, does it have something to do with the operating system? Yeah, no, it's got nothing to do with that. All windowing function truly is a function performed over a range or a window of results. Excuse me. So all windowing, with SQL Server 2005, we actually started being able to use windowing functions. We got 4 at that time. The first one being row number, which is truly just a unique number over a window of results. We have rank and dense rank, which are just dealing with ties. And we'll go through an example here in just a minute of what those truly mean and what the difference between them is. And we also have Untile, which divides rows into buckets. So with that, let's go to demos. As you'll notice, this is going to be a very heavy session, because that's what I truly enjoy the most. Hopefully y'all like it as well. All right, so with that, okay. Well, first off, let's go over what a windowing function looks like. This is the basic example of what a windowing function looks like. Most of it looks pretty similar to normal, because we're just doing a from a sales order header, and we're using the AdventureWorks 2014 database. In here, we're going to use one. Let's bump this up so we can really read it. All right. So our first one here we're going to work with, and as you play with windowing functions, this would probably be the one you work with at least starting with the most, because it is the simplest to understand and it gives you the most data quickly. So it's row number, and notice there is an underscore between row and number. Then there's the parentheses, open and close, then over. Over is how I can tell that a function actually is a windowing function, because it has to be, as I said earlier, it's over a window. So therefore they included the word over, just so you can tell easily that it's a windowing function. Then we have open and close parentheses again, but this time in here, we're going to tell it, order it by the customer ID. All this does is tell it basically that we're going to order it a very certain way. And we can do just like in normally using an order by, you can do it ascending or descending, and it works the same way. Without anything, it's ascending, and descending is you have to type it in. All right, so let's look at this. It is truly exactly like I said. So we've ordered it by customer ID. So it's just going to go through here and put the row number beside it. You notice I gave it an alias. I recommend using an alias all the time that you have use a row number function or windowing function, just because it will make life easier for you going down the road. Now I'll give examples of where it really helps. So in row number here, you'll notice we have down in the right corner, we have 31,465. So as it would make sense, at the very end, we have 31,465 rows. So it just counts up every time. That's all this does. Pretty simple. And this one is very useful. All right, so now one of the things that I truly also like about windowing functions is you can partition the results so that you see the only difference between this one and the last one is that I am partitioning by customer ID and then ordering it by the sales order ID and just working down through here. So yeah, let's run this. So now we're partitioning it by the customer ID, and the only difference that partitioning does is that when it gets to the end of a customer ID group, it will then reset the row number, so it goes back to 1. Go down through here, and you'll see it's truly flipping over and over again, and all of these seem to be, oh, there's some. For a row there was just 3 of them each time. So this one actually you see for 11,015, there's only 1. 16 is only 1. 17 there's 3 again. 14 there's 2 rows. 19 there is 17, so it just counts down through there. And the way I have this one set up is it orders by sales order ID descending. We have the highest sales order ID at the top, and then it works down, just as you expect. All right. So now that we've got the idea basically of what a row number, how it works and how an overall windowing function works, let's go through these 4 here and see what the difference truly is between all 4 of them. So with this one, you'll see that all of our windowing functions are almost set up the same way. Have row number over partitioned by customer ID, order by order date. Rank's the same way, dense rank is the same way. Entile is a little different. It only has a number here, and that's the only difference between all of these. So I've made this one a little simple, so we don't have so much data to look through. We're only going to look at 2 customer IDs, 11078 and 11300. So when I run this, you see our first one here, let customer ID 11078. We have row number, rank, dense rank, and entile. All right, so let's scroll down through here. For this first part, row number, we know how it works. Pretty simple. Rank and dense rank, we're going to see the difference here rather quickly. So when you look at rank and dense rank, there's no difference between the two as you go down through here. Order dates are very different, everything. All right, so now we get to here, and this is the one I want to pay attention to. For 11078, we get down to these 2 rows. You'll notice that the order date is the same for both of them. So there are ties between rank and dense rank. The difference between these 2 is when you come out of the tie. For 315, they're both at 14, but for 527, we come over here to rank and it's already boomed up to 16. So it skips 15 because there's 2 of them that have the equivalent. So 14 and 15, as you see here for row number, then it goes on to 16 for rank. Dense rank, on the other hand, doesn't have the skip. It shortens that gap so that it just goes to the next number, to 15 and then 16. You'll also notice that rank keeps up with row number. If there are, when it comes out of a of a tie, then it will actually go to the equivalent of the row number all the time. Dense rank, after it has a tie, it won't ever match again. Untile, on the other hand, all it's doing is pushing. It is, for example, for this one. This is why I like to give examples and work through them. We have told it we want to have 5 bins for all of our data. So we're putting all, in this case, 17 rows. We're putting those 17 into 5 different bins. So 5 divided by 17 is 3 with a remainder of 2. So every bin will have 3 different, will have a minimum of 3 rows in it. As you see here, 5 has 3, 4 has 3, 3 has 3. 1 and 2, on the other hand, have 4 because there's a remainder. So they had to go through from the very first and add 1 more in there. So that's all this is doing. Hopefully that makes sense to everyone. So let's stop here for just a second and see if there are any questions. Nope. All right. So no questions means I'm doing good, or y'all all went quiet. It's all good. All right. So let's go to the next one, because it's sort of the same, but it shows a little bit more here as well. This one has lots of fun. So as just row number works the same way. Rank and dense rank also do, but it's a little different here because, as you'll notice, this one already has a match, has a tie on the order day of 1021. So rank and dense rank are the same. Then it comes out of that. Then it has another match. We're on 12/27/2013. So rank is 11 for both those, and it comes out at 13. So it's still hitting the row number like that. Dense rank is down to 10. But here where row number is 13, dense rank is already down to 11. Then there's more matches. So this one bought a lot of things on the same day, a lot of orders on the same day. So he's racking these up. Come down through here, and by the time we get row number 27, rank is at 27, but dense rank is down to 23 because of all the matches. So that's one way you could quickly tell how many distinct rows you have. That would be a great place you could use something like this as well to see what the max number is. Also, Untile here we've told it, obviously we've kept the same number of bins. So there's 5 different Untile, 5 bins we want to shove this into. But now for this one, since there are 27 rows, we have 5 in each bin, plus the first one has, first and second one have a 6th one. That's really all the difference between these 4 windowing functions is. That one, hopefully that makes sense. You have any questions?
Seems like you have a question. Yep.
Hi, yes. What is the real life usage when it comes to Untile?
Untile is the only time I would actually use Untile is if I'm doing statistics and I'm having to group items into different groups. For example, right now I actually have, I'm doing a process to actually push push them into different groups depending on different items. So this is, once I push them into one larger group, I can then use Untile to push them into, let's say I have 30 different patients that I want to work with. If I give that group, say an Untile of 30, well, I would use an Untile of 5 to look at these 30 patients. Then I can push it down into a lower group, and I can say I can get 6 patients in each bin, so I can work with even further. There's not a lot of reasons that I could truly use that, but trying to do this without the Untitled function is not a easy matter. You definitely have to do some while loops or cursors or something to work through.
Okay, thanks.
Yep. Yeah, agree though. Row number, rank, and dense rank are much more used on an everyday basis. All right, so if no more questions, I'll go on with my little group. All right, moving on. All right, so now let's talk through window aggregate functions. They're similar, but not quite. So these are functions that use an aggregation without having to use group by. And we'll go through a demo here in just a few minutes as well to explain more of what that means. This means that they actually calculate over a window or an entire result set or a single partition. So this will make more sense, hopefully. All right. We're still working with our same database. So we all know how to do this. We've all done this 1,000 times. Select from customer ID, sum up a number from the table, group by customer ID, and order by customer ID. We've all done that a bajillion times at least. All right, but now let's do it a little more easily sometimes. So this is all I truly have to have for even the sum function to work and show me all of the data for, in this case, all customers. And I can tell it's all customers because there is no partition here. Since there is no partition by, and there's obviously no reason for an order by, not for some. Truly, let's see. So yeah, for this one, at least all you can do, since we are having an order date, sales order, customer ID, this one actually shows our total sales for all customers, period. So what I want to see, if we try to order by customer ID, will this give us an error? Actually did something different than what I was expecting, because it actually broke down by the customer ID. You can actually do partition by, and that will give you the same information. A little odd. I'm not quite sure why Microsoft decided to do it that way. It's just what it is. So that's something to play with. On this one, as I showed it earlier, I'm doing that exact thing, partition by customer ID. And that's truly the only additional feature that we've had to put here into the sum to make it a partition by, or even for some odd reason, order by, make it actually truly work through these things. Hopefully that makes sense, because as you'll notice, there is no group by. You don't need one. Not if you're just doing a sum, or actually you can do minimum as well. Now you can see the least that they actually bought from us. Obviously you can do max. You can do average. Anything that aggregates the data through, you can do. Does anybody have any questions on that?
If you guys have any question, please raise your hands. You do have access to unmute yourself. Feel free to unmute yourself. By the way, I love your presentation, Kevin.
Good. Yeah, a lot of people are not familiar with the fact that you can aggregate over a certain window. Now, this has been available since 2005, so it's a great feature that most people either don't know how to use or that you can use it. So that's why I like this presentation. All right, since no one's speaking up, I am going to accept that y'all got this, understand, and love what you're seeing. So let's move on. All right, there's window aggregate functions. So with the end of aggregate functions, one of the things we got to see was in 2005, we had 4 aggregate that we could play with, end aggregate functions. With SQL Server 2008, they had to rework SQL Server engine itself, and there was lots of work being done with that. 2008 R2 came along. There was even more work with the SQL Server engine. No more windowing functions. We only had the 4 we've had forever. But with 2012, they added some more windowing functions. One of the things we've always wanted, because that's what makes us happy. All right, so they added a fair amount of windowing functions with that, with 2012 as well. So the first group they added was accumulation aggregates, which allows framing, which is kind of cool, actually. Obviously, I'll show them in just a minute how that kind of works in the demo. So let's go through framing. So one of the things that I know I'm asked a fair amount is for a running total for my reports. So how I do that is truly just like this here. Select your stuff, sum of the total due over a partition by customer ID, order by order date, and we're going to call it customer running total. Oh, does help if I actually put us in the right database. All right, so as we see here, if we just focus on one customer, you'll see on June 21st, 2011, this customer had bought $3,756 worth of stuff. So the customer running total is $3,756. On June 20th, 2013, they bought $2,587 worth of stuff. So we add those two together to get $6,344. On October 3rd of 2013, they bought $2,770 more worth of stuff. So their running total, all told, is $9,115. And it goes through that very same process for all of these. As you'll notice, some of these people have 3 or 4 or more items they bought from us. You can actually do the same thing if you do average. I'll show that here real quick. Or just averaging the data through, it works the same way. Truly all you're doing there is since we are partitioning by the customer ID and ordering by another date or another item, then you can scroll through and you'll see where it actually is working and doing all of its stuff. So it's a little bit more than what just the previous slide showed, because we're now ordering it by a certain thing. I have been asked this several times in some of my reports for a running total. Now, this is where it gets kind of cool, because we can actually do reverse rolling totals. So as you see here, we've got a running total, which is this, and that one looks a little different than what we had before. We've added this row of stuff here. It says rows between unbounded preceding and current row. So all that's telling you is that we want to look at everything above the current row we're on for this customer and do our little bit of magic to it. Now, as you'll notice, it worked up here without having to do that stuff. So why am I doing it down here? That's just because I want to call it out. It does by default, it does this, rows between unbounded preceding and current row. Now reverse total does a little different, because obviously you have to look at everything below it. So we have to tell it rows between current row and unbounded following. So when we run this, you'll see for our wonderful 11,000 customer, we have running total adds up and reverse total adds up backwards. So the last one is 2770, as you'll see, is 2770. Then it takes these two and adds it together to make this number, and add all three, and it gets the top number here. Same thing as running total, just in reverse. Now, as you're probably thinking, why would I want to do this? I don't know, but it's a great example of where we could use reverse items and how we have to format those. As we all know, the business is liable to come up with anything at any moment. I am sure somewhere out there, someone's thinking, oh, if I could only get my people to do a reverse rolling total of this, I would be in great guns. So now you can. All right, so that's how we do a reverse rolling total. Now we can also do a rolling average, which is actually semi-cool. All right, so this one, as you'll see here for all you people who have worked with these before, I'm using a CTE just to make this a little cleaner. If you don't know what a CTE is, please go out and research, because they are extremely useful and at least makes your data a little bit cleaner to look through. So I want to show you what our stuff does here in the middle in the CTE. So all we're doing is getting from the sales order header and the sales order detail tables, getting the order date. I'm getting a sum and over partition by order date. So if I run it, you'll see here I get for February 11th, 2013, there was 5 things ordered. On May 31st, 2013, 42. January 29th, 2014, 6,764 items ordered across all customers. That's useful, but we were asked for an average of how many groups. So what we're doing here, that's the average over order by order date. Now we want to truly frame what we want to look at. So we told it, in this case, we want to look at the rows that obviously include the current row, but we want to have 10 preceding it and 10 following it over. That's what we want to look at, and that's it. So, for example, we want to look at, say, January 30th, 2012, and we want to look at the 10 days above it. So January 29th, January 28th, all the way back to January 21st. And we want to go 10 days in the future, so February 10th. So that's kind of how we want to show that. And I'll show how it runs here. You'll see how fairly quick this is. So for May 31st here, we have 825 things that were ordered, but our moving average is 10. I mean, it's 78. That's because obviously there's nothing that came before it. So we can only look at those items beneath it. So for the next 10 days, if we look at this here, we have these values. And if you just do an average of that, that is 78. Come down to the next one. We have 4 items. And plus we want to add everything above it and 10 below it. So now we're truly dropping our number, our moving average here pretty quickly. Then we come down to this one. This is the one I want to call out because that's the first one that does not include this 825. So our average is really low. So it's because we have our 10 here, plus the one we're on, and we have 10 below it. So it comes down to this point. And that's truly all there is for the moving average. As you'll notice, it bumps up here again because there's within 10 below this one, you'll notice there's going to be a high number. And 22 plus 10 is 32. So you can tell right there, that's what makes the average bump so much. That's one of the fun things you can do with a rolling average. Now I can change this to 5 preceding, 10 following. I can do, it doesn't matter, just whatever number I have to have here. Now, the fun part, I don't think it will allow this. As you see, it already gives me an error because you can't do, that would make it only do 10, let's see, 6 following and 10 following, somehow between that number. So that's truly what they want to stop you from making a mess of your own self. That's what they want to do here. So that's how we do a rolling average. And I'm sure I've worked with a couple of times where I needed to do this, and this one made it pretty easy, or at least simpler to figure out how to get done without having to go through cursors and whatnot to get it to work how I wanted to. Does anybody have any questions? All right, then moving on. So as I said earlier, SQL 2012 brought 8 new windowing functions. They actually put them into 2 different sets of items that you would work with. So the first group is called the offset, which brings us functions such as lag, lead, first value, and last value. I give a small description on what these do. There's also the other group, which is the distribution functions, which if you're working with distributions, these are very helpful. We do %rank, %discrete, %continuous, and a cumulative distribution. And with that, it's time to go to yet another demo. So let's go here to offset. We're going to look at our wonderful database again. So let's work with lag and lead. As you see, it's basically the same. It looks the same, except for the fact that one obviously has lag and one has lead. So the reason you use the difference between the two is lag looks at a previous element, or in this case, it's sales order ID is the field that we're going to look at, the one previous. Lead looks at the next one for that customer. So that's why we have it partitioned by customer ID, ordered by sales order ID, because we're showing sales order ID. That's what we want to show here. So when we run this, as you see, for customer 11,000, we have for 43,793 is sales order ID, which matches up with the next row. The last sales order ID obviously is the 43,793. And that 51522 matches up down here. 57418 matches up with the next sales order ID on the row above it, and 51522 shows the next order as the next sales order ID for the very first one. Whereas the last sales order ID for the first order they've ever done is blank, and next sales order ID for the last order they've done is blank. Yeah, that one is about as much data you can do for that one. Now, if you scroll down through here, you'll see the people that had only one order with us, like 51520 here, have no last soldier order ID or next soldier order ID. They have this order and that's it. Same for this one. That's how this works. So lag and lead, very useful if you want to show the last time this happened or the next time this happened. All right, so with that, you can kind of see how we would do a lot of work, make it just grabbing data quickly. So days since and until, it works kind of the same way. We're just going to use the date diff function to see how long it's been since they last ordered, or how many days till they next ordered. Then we can grab things like averages and know kind of how far in the future it'll be till they next order. So with that, as you see here, the true difference truly is date diff. We just want to do the number of days. We see the last time they ordered. And then we want to compare it against the order date for the current row. Same thing for the lead function. We're just having different orders. I do that only because I want it to be positive in both cases. So I look date diff between order date and the lead order date, which will give us the next order date. So when I run this, notice there's still no group by. When we run this, we see for the first one, for our favorite customer of all time, days until next is 730, which is the difference between those two dates. And between 620 and 10/3, there's 105 days. So that's came out both ways. And yeah, because it truly will just show the same number between these two. These two numbers should be the same, and these two numbers should be the same every time because you're just comparing those two dates. Obviously, it's the same thing as last time where there is no, since there's no, on the first order, there is no last order or previous order. So it shows null. And on the last order that the customer had, there's no next order. So therefore it has to show null. Now, having shown all that, I like showing this one because now we can actually clean up some of those nulls and whatnot. So with this, we can do a little something different. We can actually change it to actually doing, we can go ahead by 2 orders or behind by 2 orders or 3, 4, 5. We can do number different than just one previous. In this case, what I've done is I've actually changed it to 2. So I want to look back 2 orders. And I want to look back if there is no null, if there is no previous order in this case, I just want the date 1/1/2000. So when we run this, you'll see here, we have 1/1/2000 wherever there are nulls, and we have, in this case, our first order is shown for the third order, and if we look at the first order, it is able to go ahead by 2 orders, but that's it. Everything else would show null in our previous showing, but since we have the optional parameter of what we replace the dates with, it shows as 1/1/2000. Now, I know what you're thinking. You're like, Kevin, what if I do want to show, I want to show forward 1 order and back 3. So in that case, we'll just show back 1, and we changed our alias here just so we can keep up with it. Same thing. Since back 3 orders, this guy only had 3 orders, so he's not going to get to see any data in last. And for forward 1 order, obviously it just shows as much as it can, but for the last one, it shows that. So now you're like, what if I want to see a default parameter of, I want it to show 1/1/2000, but I don't want to include the offset parameter. I just want it to go 1 in the future. Well, sadly, all you can do is this. You have to put the 1. Now, and this is really odd to me, why they allowed this one. I can actually change this to show 0. Now, everybody think for a second, what do you expect to happen if I'm showing 0 ahead on lead? All right, everybody got in their head what we think we're going to see? So it shows the exact same row. Whatever that current data had, that's what it shows over here in forward 0 orders. In this case, forward 0 orders. So it's showing that same thing. And the same thing works for lag. Run it, and it shows the same date. Does it help? It's just something different. Now, you cannot do this. I don't think anyway. Right. One of the things it will remind you, offset parameter for lag and lead cannot be negative. Just because they don't want you to. Not sure why they allow you to get this far without the little squiggly markers, because there's so many squiggly markers that Microsoft puts down there anyway. Why not put it in there? They decided to do it this way. Whatever works for them. All right, so now what if I don't want to have the 1/1/2000, I just want to include that. So you can just delete it. Pretty simple. Then you'll see nulls. You can change this to 0. That's fine. All right. Everyone kind of got that, because that's a little bit different. All right, so let's move ahead a little bit. So first value and last value. One of the things we have here, first value, fairly self-explanatory. All this is going to show is the first time that we got an order from this customer, period. Because it will show first value, we want to see the order date, partitioned by the customer ID, order by sales order ID. Thankfully, in this case, the sales order ID is right in line with our order date, because we don't allow the customer to backdate anything. So we're good here. So for this guy, customer 11,000, our first order date was 6/21/2011, as you see here. And if you scroll down, you'll see this. Everybody's the same way. If I scroll down here to, I think it's 19. Yep, because this is the one that has multiple orders with this. The first order date was 7/15. Yep, works the same way for everyone for that customer. Now, let's work last value. We run it here. We've got last value. You see no difference between any of these. Great. Problem. Because as you notice when you look at the data for customer 11,000, it's not showing the last time we got an order from this guy. It's showing the current row. And we have it ordered by a sales order ID. So it should be showing up right. Sadly, it's not. That's because we've forgotten one very important feature by default, because we've taken all the defaults that Microsoft has given us. We should know better by now. So what's wrong with it? Because you did not include one of our favorite lines that just rolls off the tongue each time that you did work with last value. You have to include rows between current row and unbounded following. Now, I kind of get why they didn't put this in there by default, because they want you to specify how many rows you want to look through, because you could say, we only want to look at the next 10, we want to look at the next 20. But come on, Microsoft. And overall, I think this is a kind of to me at least, it's a nice to have. At least it would stop me from forgetting each time and saying, oh, why doesn't the last value work? Oh, yeah, it's because I forgot to tell it what rows I want to look at. I forgot to tell it the range. So with that I bring this one up because, like I said, almost every time I do last value, I have to run it at least once before I'm like, yeah, that's why this doesn't show up right. So I'm hoping y'all will figure out from my mistakes. Hope y'all will remember what to do or what not to do and be like, oh, this is why. Kevin said, let's do this. Save y'all some heartache. All right, so let's go to the next group. So, hang on. Forgot one little thing here. So we went through the offset groups. Now the other group that we want to look at is the distribution functions. So as you see here, I like my little notes I put here just to remind everyone what we have. The value returned by the cumulative distribution function represents the percent of employees that have a salary less than or equal to the current employee in the same department, while the percent rank function computes the rank of the employee's salary within the department as a percentage. All right, so let's show what this actually does. Works the same way as all of our other functions, partitioned by the department, order by rate. We're looking at another group of people here in the AdventureWorks 2014 database when we run it. So let's focus here on document control for a little bit. So the main difference between these two functions is the fact that %rank always has the very top one as 100% or 1 in this case, where the bottom one or the lowest is 0 or 0%. Cumulative distribution always has the top one and being 100% or 1, and the bottom one is a different number completely. It's normally not going to be 0. For in this case, since there are 5 people, it doesn't matter how many rates there are, but there are 5 different people on this one. It's just divided 1 by 5 and distributed them accordingly, because 1 divided by 5 is 0.2. So since these two guys have the same rate, it makes both of them at 0.4. And since these have the same rate, it'll be 0.4 added to 0.4 or 0.8. Where %rank does the same thing, kind of. It takes since there are 5 here, it takes 1 and 0, and well, kind of the same thing. So %rank, it makes this guy, since he has a rate at 100%, this one is the 10.25, which is at 0. It will find that this one, since it's the only number that is not within, is not the top one or the bottom one, so it throws it in at 0.5. If you do the same kind of math down here in engineering, bring that up so we can see everyone in engineering. Get rid of the sad executive. All right, so for engineering, cumulative distribution, we see that there are 9 people, so we bump them out accordingly. We have this one is not 0, it's 0.1. So because 1 divided by 9 is 0.1111. Shows all that work. And since these 3 are grouped together, but because they have the same rate, it works accordingly. %rank just divides them all out equally. Thankfully, these 3 have the same one, so you can do the little math and it comes out this way. Hopefully that makes sense. Now, truly, as we said earlier, you probably won't use these a lot, but if you are doing statistics, and as everyone is seeing in today's market, you're doing more machine learning, you're doing more AI work, doing work with a lot of statistics. I'm seeing that I'm doing a little bit more these days with these kind of functions. Hopefully this work helps y'all as well. All right. For the last group, hopefully everyone kind of understands these. So let's go on to the last one here. This one is probably even less used than the one I showed above here, cumulative distribution %rank. That's why I include these this notes, just so y'all can pay attention and see what all this stuff does and see the difference. The main difference between these is this one is continuous distribution, while this one is discrete distribution. And I'll show you here. So what I've been asked to do is find the median employee in each department. This is where this one, you can see the difference. So since I'm taking the median, and this is normally what you will take when you're working with these two functions, to find the median, the only difference between these is median continuous actually will show a number that may or may not be this rate, where the median discrete is going to be one of these numbers that are showing in rate. So for that, we actually show, you'll see these are done a little differently than earlier, than other windowing functions. You still got an over, but you now have the within group. And since we had to order it by rate, and you have partition here. So it works a little different, looks a little funky, but after a little bit of playing with it, you'll see how useful it can be if you need to grab these numbers. The only one I've ever had to work with is truly is 0.5. I've never had to use any others, but I'm sure statistically you could play with around it, get some other value that you need. but you'll obviously have to work with others to see why or where you would want to use those. All right, and also, I'll give this one out free as well. A friend of mine came up with this website to show what percentile continuous does and why you would use it and how it works actually as well, because there's an Excel spreadsheet on this site that goes through and shows everything on there. So I highly encourage you to look through that. Now, with that, I'm going to show a couple more things because I see I have about 10 more minutes here. Make sure to, if you want to learn more about windowing functions, I highly recommend this book by Aunt Kathy. Yes, if you don't know Aunt Kathy, please learn about her. She does great work, lots of work with windowing functions and many other presentations as well. This book from A-Press is great. Also, if you have ever heard of Itzhak Ben-Gan, you will need this book. You will go into very deep corners of windowing functions that most people won't get. Most people won't get to play with, but it is very helpful to know the ins and outs of windowing functions. And with that, I also have on my website an example, some exercises you can work with of her windowing functions. So learn more about them, learn what they can do with them, how to use them. There's some great examples on there. I like them anyway. I've been told a lot of people like them as well. So always come to my website. You can play with it. The answers do exist, or my answers anyway. Great ways to learn about it. So with that, I actually want to leave you with another thing on how I've used windowing functions over the last few years to learn a lot of work for stuff. This is where I truly find the most useful work from windowing functions. So one of the things that, for example, we've been asked for is to find the first row of each postal code for a table. So in person.address here, same database, we're asked to find for every postal code, we want to find the first address ID of anything that's used this, has that same postal code. So since there are 19,614, and I scroll down through here, and there's a lot of different postal codes. I am not going to go through this by hand, not going to go through it by Excel. Nope, I'm using the power of SQL Server. So how I do that is just like this. So all we're doing here is using the row number function, partitioning it by the postal code, and ordering it by address ID. So that will give us this. See, there's nothing truly different until you get out here to the very end. It shows our row number column. Now this is where it comes in useful to just throw in the as row num, because if you don't, you could do that, but then there's no way to get the next part because we can't address this column here. So we put this back. I see a lot of people call it row num. I call it, yeah, in some cases I'll call it row num, some cases RN. Just be consistent. I don't care what you call it. We call it where row num equals 1. And notice, yes, this does take a couple of different things to actually make work. If you put this into a CTE, you obviously don't have to have Z. Down here, I just call it an alias of some type. But you will have to call it in two different parts because you can't say where row num equals 1 in here, because obviously you don't know what row num is when you're within here. So now when I run this, it gives us all 661 distinct postal codes and the first address ID that is for each one. See, it goes all across the board here. We've ordered it, since we ordered it by postal code, it's pretty quick. All right, so now, first thing I do want to caution you, you'll see a lot of people that don't want to use row number. They want to use rank. There's a problem with this. Do not use rank because rank does allow ties. If there is a duplicate, in this case there won't be since it is address ID, and address ID changes each time, there won't be a duplicate. But A lot of people try to use rank or dense rank because they think it's going to be different. Nope. Yep. Since rank and dense rank allows ties, do not use this. Row number will make sure there is only one row each time, and that's it. I cannot stress how many times I've seen rank and I'm like, this doesn't work. It fails because rank does allow duplicates. Row num does not. Please change to row num. Period. I have people fight me on it too. So, and I'm like, let's go through it, and I'll win. So, all right. So next big sample I like to do, I'd like to leave you with, find the gaps in address ID. So if we look through this one, you see there's 19,614 rows, but if we scroll down to the bottom here, it's 32,521 address IDs. That means somewhere, sometime, somebody got delete happy and got rid of some of our data, or we skipped a few. There's no telling what happened. So how would you figure out the gaps, the true gaps in this one? So we can take one of our big examples that people like to do is they'll say, oh, I can create a tally table and see what's different. Well, yeah, you could, but that would truly give you the list of numbers that don't exist in this address ID column. I didn't ask for that. I asked for the true gaps. What's missing? You can write up some other ways. There are some other things you can do. Let's do it the simplest way. Let's use windowing functions. This is it. This is the entire process it takes. Select your ID. So let's talk about the subquery here. Select address ID, and then we want to look at the next address ID, and you order it by the address ID. Next row is, we're calling that next row number. We want to say the next row number minus the current address ID. We just want to see what the difference is. Then we want to check to see where the difference between those, which since we call this the difference, we just want to see where it's not equal to 1. And there we have the entire gaps itself and how big they are. That's it. That's how simple getting that gap truly can be. So this is for a lot of places you'll have a island and gap question. This is what truly the best answer that I have found for this, and possibly the easiest to actually show. So with that, I do want to leave you with my website, sherpaofdata.com, where we talk about all kinds of different items that I think are very useful for anybody. You can always reach me on LinkedIn, Twitter, or email. And with that, I turn it back over to Jean.
Thank you so much, Kevin. That was a very great session, especially data analysts people and data science people. They would be happy right now, even SQL developer. Right, and Kevin, would you mind if I share my screen for 1 second just to go to remind all attendees to register to feature data-driven event?
All yours.
Perfect, thank you. Let me quickly do that. I would love to remind you guys, we have our first ever feature data-driven event. We have a tons of great speaker for you. Please register. Just type datadrivencommunity.com. You guys must be able to access to this to our website, and then click on register to save your spot. And then don't forget to share this with your peers as well, because we have a lot of great speakers, speakers you would love to hear every day, right? So they are, and it's a free event. So feel free to, for example, go and save your seat. And then also, if you want to find us, so you can find us here, right? right? And then that's all I want to remind you all. Kevin, if anyone have any questions, feel free to ask Kevin. Thank you so much, Kevin, for your sessions. So we are waiting for all attendees who have questions to raise their hand, and we will be happy to please unmute yourself and ask the question.